Welcome to my presentation. In this presentation, we shall see how to solve system of linear equations in two variables. Okay, so let me write the example here. We want to solve the system of linear equations, which is 4x minus 3y minus is equal to 15. This is equation number 1, and then x plus 2y is equal to -1. This is equation number 2. So the steps we want to follow here are as follows. Step number 1, we want to write an augmented matrix for the system of linear equations. So the way we do it is we pick the coefficients from equation for x and y from equations 1 and 2 and write them out in an augmented matrix format. So 4 is the coefficient of x, -3 is the coefficient of y, and the constant number is 15. In the second equation, the coefficient of x is 1, the coefficient of y is 2, and the constant number is -1. So this is our augmented matrix. This is our augmented matrix. This is our augmented matrix. I'll write down the step 2, and then I would like to use that procedure, that process to this particular problem. Use matrix row operations to simplify the matrix. Our goal is to obtain a matrix of the form. This is our goal, is to obtain the matrix of the form 1a b 0 1 c, like that, and then we want ones along the diagonal and zeros below the diagonal. We want to achieve that, and to be able to achieve that, we're going to look at step 1. We're going to look at the augmented matrix and interchange row 1 and row 2, and then to do that we're going to write row 2 as row 1 now, like this: 1 2 -1, and then row 1 becomes row 2, that will be 4 -3 15. So, and now by looking at this, we want to, by looking at the low row echelon form we want to achieve, we want to look at the diagonal all the time. We want to look at this diagonal all the time, and we want to say, we want to make the elements below the diagonal 0. We want to make this element equal to 1, but we want to do this one step at a time. So I will say that we want 0, we want 0 in this location. We want 0 in this location, and therefore we're going to use the row operations to be able to achieve that. So we'll call that as step number 3, and in step number 3 we're going to perform that operation here, and that is 1 2 -1, and then the operation we're going to do here is as follows. The new R2 is going to be equal to -4 times R1 plus R2, and the way to do that is as follows: -4 times 1 plus 4, -4 plus 4 is going to be equal to 0. The second column, we have -4 times 2 minus 3. -4 times 2 is -8. -8 plus -3 is equal to -11, and then -4 times -1 minus or plus 15. Negative 4 times negative 1 is positive 4. Positive 4 plus positive 4 yeah, this should be a, oh sorry, this should be a negative 15 here, this should be a negative 15 here, there should be negative 15 here. So this is a negative positive 4 plus negative 15 is going to be equal to a negative 11, and therefore we're going to close this, and when we rewrite this in a much more cleaner manner, this is going to look like this: 1, 2, negative 1, 0, negative 11, negative 11. And now when we look at this, we want a 0 in this location. We have achieved that. We want a 1 in this location, so I'm going to write we want 1 in this location. And the way to achieve that is by performing the row operations, and I'm going to write that as step number 4. And in here we're going to perform this operation: 1, 2, negative 1. The new R2 is going to be equal to existing R2 divided by negative 11. And how do we do that? We have 0 in that location. We are dividing by negative 11, so that value is going to be equal to 0. We have a negative 11 in the second row, second column. When we divide it by negative 11, that is going to be equal to positive 1. In the second row, third column, we have a negative 11, and if we divide that by negative 11, that value is going to be equal to 1. So therefore, when we simplify this, or when we rewrite this in a cleaner manner, it is going to look like this: 1, 2, negative 1, 0, 1, 1. So we have achieved the row echelon process, row echelon form for this system of linear equations in 2 variables. We wanted 1s along the diagonal, we wanted 0s below the diagonal, and therefore we have arrived at a augmented matrix which is going to give us the solution from this point on. So step number 5 is we're going to write the system of linear equations from this augmented matrix. So we can write this one as x plus 2y is equal to negative 1. That will be our equation number 1. X in the second one, x is 0, so therefore we have only y is equal to 1. This is our second equation. So from here we got the solution. We got the value of y as equal to 1. This is one of our solutions. In step number 6, we're going to use the back substitution, and that is what we're going to use, the back substitution, and then solve for x. So if we take equation 1, which reads x plus 2y is equal to negative 1, if we substitute the value of y as equal to 1, x plus 2 times 1 is equal to negative 1. So x plus 2 is equal to negative 1, or x equals to negative 1 minus 2, that is going to be equal to negative 3. Therefore the value of x is equal to negative 3. The solution therefore is the value of x equals to negative 3, the value of y is equal to positive 1. So we got the solution. And we should be able to check our answers by substituting it back into the original equation. And the way to do that is as follows. Check. Step number 7. In here we want to check our answers when x equals to -3 and y equals to 1. Our given equations are 4x minus 3y, this is equation number 1, is equal to -15. For x, we're going to substitute -3, and for y, we're going to substitute 1, and that should equal to 15. So -4 times -3 is -12, and then minus 3 is equal to -15. So -12 plus -3 is -15 is equal to -15, and therefore the left hand side is equal to the right hand side, and therefore the value of x equals to -3 and the value of y equals to 1 is exactly correct. We can also check it with the second equation. The second equation, what we have, the original equation is x plus 2y is equal to -1. When we substitute the value of x as -3 and the value of y as 1, we should be able to get -1. So -3 plus 2 is equal to -1. -3 plus 2 is equal to -1, and that is exactly equal to what we have on the right hand side. And therefore, the values what we have arrived at, that is x equals to -3 and y equals to +1, satisfy both the given equations, and therefore we have a complete solution. This is the way we want to solve system of linear equations using matrices. In my next presentation, we shall look at some more examples to solve matrices using system of linear equations using matrices.